General Specification for Valves, Part 9. All valves supplied for oil and gas service must undergo comprehensive inspection and testing to verify compliance with dimensional, mechanical, functional, and sealing performance requirements. Inspection and testing shall be performed in accordance with API 598 as a minimum, and where applicable, supplemented by BS EN 12266-1 and ISO 5208 for seat tightness, hydrostatic strength, and fugitive emissions testing. Valves must pass both shell and seat tests before being released for shipment, with pressure testing performed at the rated differential pressure or as otherwise specified. Hydrostatic pressure tests shall be conducted on all valve bodies and bonnets to verify structural integrity. The shell test pressure shall be 1.5 times the maximum allowable working pressure, MAWEP, at ambient temperature. Each closure element, including seats, must be leak tested with water or compatible fluid at a pressure of 1.1 times MAWP. Test durations shall follow the applicable code requirements based on valve size, material, and pressure class. No visible leakage is permitted from any external point during this test. For valves intended for gas service, high-pressure pneumatic testing is mandatory for all isolation valves in pressure class 2500 and above, and for metal-seated valves in any class. The pneumatic test shall be conducted at 110% of design pressure using clean, dry air or nitrogen. This test is critical to verifying tight shutoff and bubble-tight performance under gaseous media. Test pressure, medium, leak detection method, and duration must be documented in the test reports and certified by the inspector. Fugitive emission testing is required for all valves designated as low emission or installed in services with environmental controls. These valves must be tested in accordance with ISO 15848-1 for type testing and ISO 15848-2 for production testing. If emission class A, HS is specified, production tests must demonstrate consistent results across sampling batches. Where waiver of production testing is requested, vendors must submit type test reports not older than 2 years with proven testing history in identical valve types, sizes, pressure classes, and test conditions. Non-destructive examination NDE shall be performed in accordance with governing standards such as ASME Section 5 or ASTM specifications. Radiographic testing, RT, ultrasonic testing, UT, magnetic particle inspection, MPI, and dye penetrant testing, DPT, must be applied to valve components as defined in the applicable MES specifications or material requisition. NDE results must be traceable to heat numbers and casting forging identifiers. Final NDE records shall be included in the valve dossier submitted with each batch. Positive material identification, PMI, testing shall be performed for all critical pressure-retaining parts made of stainless steel, duplex, or CRA materials. Testing shall verify the chemical composition and ensure correct material selection per design requirements. PMI reports shall clearly indicate location, method, instrument calibration, and match valve body or part serial numbers. Supplier must submit a PMI inspection matrix covering all valves offered and confirm 100% coverage for sour service or critical isolation valves. Valve functionality shall be verified by mechanical operation tests conducted before and after pressure testing. These tests confirm proper stem travel, torque levels, position indicators, gear alignment, and responsiveness to actuation. Torque testing for quarter-turn valves, ball and butterfly, shall verify that required opening and closing force is within specified limits. Valves equipped with gear or actuator interfaces must be function tested with the specified operator or simulated torque tools. The manufacturer shall develop a detailed inspection and test plan, ITP, including all witness, hold, review, and record points required by the purchaser or third-party inspection agency. The ITP must specify the applicable standards, acceptance criteria, test media, cleanliness levels, pressure gauges, calibration certificates, and cleaning/packing procedures post-test. All test equipment must be traceable to valid calibration certificates within the preceding 6-month period. All final inspection documentation must be compiled into a traceable valve dossier, including hydrostatic and pneumatic test reports, emission testing results, NDE certificates, PMI reports, dimensional inspection logs, material certificates, ITPs, and inspector sign-offs. Each valve shall be tagged with a unique serial number and stamped with identification details, including pressure rating, size, and material class. The complete test dossier must be submitted for review and approval before shipment release. General specification for valves, Part Tech 10. Inspection and testing continued. Each valve must be subjected to a thorough dimensional inspection prior to pressure testing. This includes verification of critical dimensions such as face-to-face, end-to-end, flange thickness, bolt circle diameter, valve bore, stem projection, and operator interface dimensions. These checks must be performed using calibrated instruments, and inspection records shall be maintained for each valve batch. Tolerances must align with applicable SME and API standards. Any deviation from nominal values must be evaluated for functional and structural acceptability, with nonconformities documented and dispositioned. Where valves incorporate hard-facing or weld overlays on seating surfaces, additional testing is required to verify the integrity of these layers. This includes hardness testing using portable Rockwell or Vickers instruments, bond strength evaluation where specified, and visual examination for cracks, porosity, or delamination. Weld overlays must meet minimum thickness and hardness requirements defined in technical specifications and welding procedure qualification records, PQRs. Evidence of welder qualifications and process parameters must also be maintained and submitted upon request. Cleaning and preservation inspections shall form a mandatory part of the final QA/QC hold point. Following pressure testing, all valves must be thoroughly cleaned to remove test fluids, rust inhibitors, or debris. The internal surfaces shall be dried and flushed with special care taken to protect soft seals and seat surfaces. Cleaning procedures shall be included in the ITP and must specify the use of lint-free cloths, nitrogen purging, or approved degreasing agents. The internal cleanliness shall be verified by borescope or visual inspection before final packing. Valves for service in oxygen, chlorine, hydrogen, or cryogenic applications must meet additional cleaning and testing requirements. Cleaning for oxygen service shall comply with ASTM G93 or equivalent and include a validated cleaning process, cleanliness verification, e.g. swipe test, UV test, and complete documentation of handling and packaging. Valves for cryogenic use must undergo cold performance testing at defined temperatures and verify seat leak integrity after thermal cycling. Sampling plans for fugitive emission production testing must be developed in line with ISO 15848-2 or company-specified procedures. Sampling plans must define the number of valves to be tested per batch, the test conditions, acceptable leakage thresholds, and corrective action procedures in case of failure. Suppliers shall submit a matrix showing how tested valves represent the full range of pressure classes, sizes, materials, and packing configurations. All emission test equipment used must be properly calibrated, and test results must clearly correlate with valve serial numbers. Actuated valves must undergo complete functional testing with their respective actuators, including stroke time measurement, fail-safe operation verification for spring return types, and response under control signals. For electrically actuated valves, tests shall include voltage tolerance checks, limit switch operation, and feedback signal verification. Pneumatic actuators shall be tested for stroke pressure thresholds, air tightness, and fail-close, fail-open reliability. Functional test reports must detail input-output conditions, travel times, and response behavior. Witness and hold points must be defined for all critical stages in valve manufacturing and testing. Purchasers or their appointed inspection agencies shall be given prior notification for witnessing hydro tests, shell tests, fugitive emission tests, and final dimensional verification. Suppliers shall prepare and submit a detailed inspection schedule indicating valve types, sizes, test dates, and associated inspectors. Any missed witness points without prior approval may result in test repetition at supplier's expense. Where destructive tests such as sectioning or metallography are required, for example, to qualify overlay procedures or verify weld penetration in critical sealing surfaces, they must be performed on sacrificial samples representative of production valves. The supplier shall provide full reports, including etched cross-sections, weld maps, and metallurgical analysis to validate conformity with design requirements. These tests form a key part of type qualification and are typically not repeated on production units unless otherwise specified. All inspection and testing activities must culminate in the preparation of a valve test dossier, VTD, also referred to as a manufacturing record book, MRB. The VTD must include the certified test reports, datasheets, material certificates to EN 1N204 Type 3.1, NDE results, emission testing records, functional test reports, PMI certificates, hardness test data, visual inspection forms, inspection release notes, and a signed inspection and test plan. Each dossier shall be unique to the valve serial number and digitally indexed for long-term retention and traceability. Approval of the VTD is a prerequisite for final shipment and invoicing.